So the homework, and I'm just going to focus on the chemistry part, was Unit 1, Lessons 7, 10, and 11. And I want to remind you that some of these questions, some of these lessons are also combined for grade 10. So if you notice some of the questions seems harder, or it's things that I haven't taught you, it's normal. Try your best. The lessons explain everything. So, give it a try. It's hard to find the exact same thing we do in grade 9. That's why you might find some questions that are a little more advanced. So we'll go on into 7, and you guys stop me if you have any questions. I think 7 was a pretty decent quiz. If you have any questions, please unmute yourself or put it in the chat. No questions, so I'm going to ask you a question, and I'd like to get your responses. Let's go with number 4. Which of the following is a physical change? So is it 2 substances being mixed, leading to the production of a flame? 2 black substances being mixed, forming an orange substance? Salt mixing with water, leading to a salt water solution? Or is it last, sodium reaction with chlorine, forming a sodium chloride? So which answer is it? Go ahead and answer on the chat. Let's see. Let's see those answers. Well, no answers yet. Oh, there we are. Tyler says the third one. Yes, salt mixing with water is just a solution, a dissolution. Nothing special. It's still salt in the end. All the others, you're producing flame, change of color with the orange substance. And here you're completely creating something brand new that wasn't there before. Okay. Next is, this was for lesson 7. Then there was lesson 10, chemical equations. Let's go with number 2. 3H2O means what? 3H2O. Is it the first one, 2 molecules of water containing altogether 3 molecules of water containing altogether 6 hydrogen, 3 oxygens? Is it the third one, 3 molecules of water containing altogether 3 hydrogen atoms, 2 oxygen atoms? Or the last one, 3 molecules of water containing altogether 2 hydrogen atoms, 1 oxygen atom? Let's see your answers. Let's go on the chat. Well, what do you think? 3H2O, what does that mean? Nope. Adil, try again. Yes, Veronica, the second one. Look, 3 water molecules means I have 6 hydrogens because I go 3 times 2, 6. And 3 times 1 is 3. Right here. Okay, I'm going to go over this today, and I think after today's class, you'll understand this a lot more, Hadil. Let's do this one. What do you think? This diagram represents which correct formula? Well, yes, excellent. The fourth one, 2 molecules of CO2. No, Dula, not CO4. Look, each separate one, I have C with 2 O's, that's CO2. Not CO4. CO2 twice. Got it? Yes, the fourth one. Good job. Okay. So actually, I'm not going to do the rest because I think after today's class, you will be able to do this a lot easier. So if you did this quiz and you bombed it, you can retry it later on after the lesson. I should have assigned this one today, actually, chemical equation. This should have been today's homework. So if you haven't done it after today, you will know how to do this, okay? Now let's move on to the last one, types of reaction. Any questions about this quiz for those who did it? No questions. So let's see. Number one, if you know what to answer, I have water that becomes hydrogen and oxygen. Was that a synthesis, a double displacement, a single displacement, or a decomposition? So double displacement and single displacement is a grade 10 subject. So right away, I'm telling you, it's not one of those two answers. It's either a synthesis or a decomposition. So let's see your answers. George?
Yeah.
What do you think?
I think it's decomposition.
Yes,
reaction.
Why? Yeah. Why?
Because it's like decomposing into two different, what's it called?
Elements.
Elements.
Yeah, that's it. You're starting big and you end with two separated elements. That's good.
Yeah.
Whereas look at the next one. You start small and you end bigger. Yeah. So that would be what?
That would be a single.
Synthesis. No, never mind the single and double. Synthesis or decomposition?
Synthesis.
Yes, synthesis. Very good. I can tell you now the answer for number 3 because it's a grade 10 subject, the double and single displacements. Take a look at this one. The zinc takes the place of hydrogen. It's like a switch here. So you get, look, zinc now is with chlorine and hydrogen is on its own. That's why this is called a single displacement. It's one element that switches. Okay? But the rest is stuff. Oh, this one too. This one is grade 10. Acid plus base give you salt and water. So this is an acid-base reaction. Like I said again, it's hard to find the exact exact questions of grade 9 only. So it happens sometimes that it's mixed with grade 10. Okay, if there are no more questions, I'm going to move on because we do have other stuff to do. Okay. So for this part, I need you to take out the paper I put on Schoology. George, do you see it?
Yeah, I see it.
Okay. Did you print it? I can't remember what you said. Okay.
Yeah.
Sounds good. So before I fill out the paper, I just need your attention for 1 second. So in life, you must have heard of balance in life. I'm sure you heard about this. So if I start with something, let's say I want to make mashed potatoes. Well, for me to have mashed potatoes, I have to start with potatoes. And I have to boil them and mash them and add butter and milk and salt. And then you end up with mashed potatoes. Okay? But I wouldn't have mashed potatoes if I didn't have to start with the potatoes and the butter and the milk. Okay? So the potatoes didn't disappear. They transformed, they rearranged for me to get mashed potatoes, right? So this is what I'm calling balance. If I have 10 potatoes, then I'm going to make a nice amount of mashed potatoes. If I have only 2, then this will be only for like 1 person. It's not suddenly I go from 2 to 10. Where did it come from? So there's no such thing as disappearing substances or appearing. They are there, but they rearrange, they transform to get what you have, like a new product, okay? Same goes with burning paper. If I burn a piece of paper, I get ashes, obviously. But I wouldn't get ashes if I didn't have paper to begin with, okay? So things can be constantly rearranging, transforming, so that at the end you get a new substance. But keeping in mind that I had to have certain things at the beginning to get my final product. It's like these Legos here, okay? So I have 2 yellow, 1 red, 1 green, right? I can take them apart. This one's harder. There we go. Okay, now they're all separated, which is a decomposition, but they're still there. They didn't disappear. They're still there. I can rearrange them now and to give me something completely different. You see? So, question, did the mass change? Did the mass change? George? I think you're the only one unmuted.
What's that?
Did the mass change?
No.
When exactly? Because I started with this, like all of the Legos together. Then I separated them, and then I rearranged them.
Yeah.
So mass didn't change. Okay. And I started off with 2 yellow Legos, 1 red, 1 green, and I ended with the same amount: 2 yellow, 1 red, 1 green. Nothing disappeared, nothing appeared, things just transformed. Okay, so the same goes with chemical reactions. Same idea. Okay, or you can even think about words. Imagine with just 26 letters, you're rearranging the letters to make all kinds of words and all kinds of sentences and paragraphs and books. And you can do that in like, what is it, 2 or 3 or 4 languages. I think Italian and Spanish use the same alphabet roughly. So with the same 26 letters, you're writing millions and millions of words, okay? So it's all a question of rearranging, and you get still the same at the end, okay? The same elements are still there, okay? So to understand this, I'm going to share the screen, the Smart Notebook screen. Oh, let me just let me do a new one. Okay. So now if we take chemistry, I'm going to start with sodium and chlorine. I want to make salt, okay? And that gives me NaCl. So far, up until now in your experience in your science classes from grade 6 all the way to grade 9, you see a reaction like this, and you don't stop and think that this is not a balanced equation. This is not right. This is like having Legos that appear out of nowhere, okay, or disappear. So now you have to understand that this is not a balanced equation. So if we take a look, how many sodiums do I have? And oh, just a reminder that on this side, these are all the reactants. And on this side, these are all the products. Okay, so on this side, how many sodiums do I have, everybody? Just 1, right? And on this side, I also have 1. So so far, it's okay. Well, where it's a problem, it's the chlorine. Chlorine, I have 2 over here and only 1. So this is not balanced. Where did the Lego piece go? It's not possible. It doesn't just disappear. Okay. So what you have to do is add pieces to the Legos to make it even on both sides. So let's use colors here just to make it more visual for people that are visual like myself. Let's say sodium is red, and let's say chlorine is blue, like that. Okay, and let's make this really visual for you. Okay, like that. And this is a plus. And Na is a red circle, so copy paste it there. Oops. And the chlorine right there. Okay, so right away you see I have one red circle, one red over here, but two blues and one blue. It's not right. So on this side, I'm gonna need to add an extra blue, but I can't. This is one thing in chemistry. I can't just split this. We're not able to do any of that. You can't split. You can't add numbers here at the bottom. This is not part of the chemistry rules. Is if you add a number here, then it's like an entirely different molecule. This is not possible. So you cannot do that, okay? So the only thing I can do is add more circles. So if I have two here and only one, then it only makes sense that I need an extra one here to make it equal. So what I'm gonna do, I'm gonna add an extra salt molecule. So now this works out. I have two blues and two blues, but now I have a new problem. I have two reds on the product side and only one. So this means I'm gonna have to add an extra red over here. So it balances. So now it works out. I have two reds, two blues, and here I also have two reds and two blues. What does that mean? Over here, you see now you write your total. I have two sodiums, so I'm going to write a big 2 here. See, we call these coefficients. Chlorine stays as is, I didn't touch it. But here now I have two salt molecules, so I put a big 2 here. See? And by adding a 2 here, it actually, imagine like you have a big parenthesis here, it multiplies everything inside. So 2 NaCl's means this drawing, 2 molecules of salt. All right? If you understood this, can you put a 5 in the chat or a 3 so-so? Go ahead. Wonderful. Okay. So let's try now with the paper. Can you take the paper out that I asked you to print? Let me just share the screen with you. This one. So total, and this box is very important, the total of each kind of atom on the left must be equal to the total of each kind of atom on the right. That's what we just did now with the circles. So you can only put a big number in front of the element or compound. And the big number is actually called, the proper term is coefficients. The big number multiplies all the atoms that make up the element or the compound. Okay, so like just if I put, let's say I have, just stop the screen again, hold on. I'm just going to share the screen. So like, let's say I have H2O, like that. Okay. Well, H2O is 1 oxygen with 2 hydrogens, right? Right? So if I put a big 2 in the front, that means I have this twice. So this and another one next to it. Oops. If I put a big 3 here, then I have a third one. See? So by putting a 3 in the front, oh, now it froze. Okay, no. By putting a 3 in the front, it multiplies everything in the molecule. It's like in algebra. So that means I have 3 times 2, 6 hydrogens, and 3 times 1, 3 oxygens. And look here, 1, 2, 3 oxygens. 1, 2, 3, 4, 5, 6 hydrogens. Got it? Okay, back to this. So let's see. For those who didn't print it, just write this formula. Don't write every single thing right now, just the formula. Go ahead. So I want to create acid, hydrochloric acid. So I need hydrogen, H2, plus Cl2 gives me HCl. And then I use the drawings to help visualize. So that's 2 blue circles, 2 red circles. Give me, if I leave it as is, 1 blue circle, 1 red circle, which obviously does not make sense. It's not balanced. Things don't just disappear. So I have a little table here that I use as a verification tool. You can use it too. It is optional, but I recommend when you start. I froze, eh? Am I frozen for everybody? Okay.
Yeah, I miss you freezing.
There. Hi, am I still frozen?
No.
Okay, sorry about that.
No.
Okay, what was I saying? Oh yeah, here. I'm here now. All right, so let's count. On the reactant side, right now as is, how many hydrogens do I have? Hadil. In total, how many hydrogens do I have?
2.
Yeah, so we write it 2. And how many chlorines?
Also 2.
Yep. Okay, now on the product, how many hydrogens do I have?
1.
Yep. And here, how many chlorines?
Also 1.
Yeah. So you see, this is not equal. 2 and 1 is not right. It's not balanced. Something disappeared and that doesn't exist in the world. So what do I have to do to 1 to make it equal to? 1 times what gives 2?
1 times 2.
1 times 2. 1 times 2, 1 times 2. Yeah. So what does that mean? Look, I multiplied by 2 on the product side. So I multiply here. You see the 2 here in red? This is where I added my 2. So now we can review our answer. How many hydrogens, Hadil, do I have now that I've added the 2 on the reactant side?
On the yellow part?
No, on the reactant side, the left side.
2 hydrogen and 2 chlorine.
And products, now that I added the 2?
Also 2. Also 2.
Yeah. So now this is balanced. Okay. And pretend it's as if you had an invisible parenthesis here. We don't write the parenthesis, but pretend it's an invisible one, and it multiplies everything inside. Okay. All right, let's do the next one. All right. So H2O, water, decomposes into hydrogen and oxygen. So let's start with Stefania. Do you hear me, Stefania? Stefania del Santo. ¿A dónde está? Stefania is not here. Faris.
Wait, Miss, are you sharing your screen?
Oh, yeah. You don't see it?
No, I don't see it.
That's odd. There's a red circle around it. Okay. Now do you see it?
No, I still don't see it.
Belolo. Why is it glitching today? That's odd. And now what? You see it now?
Maybe I'll leave and rejoin.
Okay. But how about everybody else? Stefania, do you see the picture?
I see it. I see it.
Oh, okay, perfect. Okay, Stefania.
Now I see it.
Now you see it. Okay. Stefania, so can you tell me right now, as is, this is not balanced. Look, I have one green circle, but two here. This doesn't make sense. So how many hydrogens do I have on the reactant side? Olivia, Stefania. Nicholas, you have to go? Okay, so you have to complete this paper, please, because that's what we're practicing today. All right. You can watch the rest of the video. I'm recording it. You can watch it. Okay. Yes, Stefania, you said 2 hydrogens, yes. And how many oxygens on the left so far? Just 1? Yeah. Now on the product sides, how many hydrogens? Stefania? No. 0 does not exist. And take this too. Take the paper. Because that was 2, was you. This one too. Okay. Okay. Sorry, that was my son. We were saying, Stefania, 0. That's a good point to make. It's a good mistake to make because there is no such thing as 0 in chemistry, like in balancing anyways. 0 means it's not there. And you can't just cancel something. It has to be there. So 0 is not an answer. Look, on this side, how many hydrogens do I have? Stefania. Yes, 2. So far hydrogen is okay. Let's see oxygen. How many oxygens? How many oxygens? No, where do you see 4? Look, 2 here. 2 oxygens. 2 green circles. Okay, yeah. So now we know the problem is here with oxygen. Okay? So I'm gonna have to do 1 times what? Gives 2. 1 times 2?
1 times 2.
Gives 2. This means that on the reactants, oxygen, I have to multiply by 2. Oh, over here. You have to multiply by 2 where the oxygen is in the molecule, in the formula. So you understand that this multiplies hydrogen 2. So now let's go back over here. You see, I put a 2 in the front of H2O. Let's do the calculation again. So, by the way, those who are writing, just write this formula once. You don't have to keep writing it over and over. All right. So now that I've added the 2, let's count. How many hydrogens do I have in total? Stefania. How many hydrogens do I have in total? The blue circles. Can someone help Stefania out? Maybe she's having trouble. George, perhaps?
Yeah.
So how many hydrogens do I now have after adding the 2?
Are we looking at after the arrow?
Hydrogen. H, hydrogen.
Well,
On
there's
the
1,
reactant
2,
side.
3, 4. There's 4.
Yep. And, oh, I forgot here. I didn't put a 2 here. I had to put a 2 here because now that I have 4 hydrogens, and before I only had 2, I have to multiply that by 2 as well. So now, how many hydrogens do I have on the right side, George?
8.
On the right side,
Oh.
products.
Card. Is that the green or the blue still?
2 times 2.
Oh, 4.
2 times 2. Yep, 4. Good. Now oxygen on the left. How
2.
many oxygens? Yes, because the big 2 here multiplied everything inside. 2 big green circles. And how many on the right, George?
2.
2 also.
4.
So
Yeah.
this is a balanced equation. The answer is 2, 2, and 1. Okay. You could put the 1. You don't have to. Some scientists, most scientists don't. But if you want to, you could. It's like in algebra, like if I had x, it's the same thing as 1x, correct? We don't bother writing the 1x. You know that x is 1. 1x is the 1. So you don't have to write the 1 if you don't want to. Okay, next one. This is actually, this is the example we did together earlier. We have a question? Okay, no problem. Stefania. So here again, I have 1 sodium, 2 chlorines, 1 sodium, 1 chlorine. So I have to add a 2 here in the front. By adding a 2, now I have 2 chlorines, but I also have 2 sodiums. This means on the left side, I have to add a 2 in the front. Now we count again, 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. And the final answer is 2. This one we did already, 2 and 2, 2, 1, 2. So I know it sounds like gibberish right now, but trust me, you will get the hang of this and it'll become like a puzzle, like, you know, a challenging puzzle. So I'm going to give you 3 minutes to do number 1, and then we'll solve it together. Give it a try. And the key to this is to practice. The more practice you do, the better you get at it. So I'll do the first one with you, and then you do the next one by yourself. So you look, zinc. I have 1 zinc. I have 1 hydrogen. I have 1 chlorine. This one. Okay? On the right side, or products, 1 zinc, 2 chlorines, and 2 hydrogens. Oh, problem is here. So to get to 2, I have to multiply. 1 times 2 equal 2. 1 times 2 equal 2. This means on the left, I have to multiply hydrogen and chlorine with 2. I put a 2 here. Got it? So now, this is my balanced equation. Okay, for this one, number 1, did you understand it? Put a 5 if you understood, and a 3 so-so. Because it's really practice. You'll get the hang of it. Hadil, yeah. You have to practice. The more you see them, the better you get. Okay?
Miss Dimitri,
Yes.
do
Yeah.
we need to put the times 2 every single time?
No. No, I'm really doing baby steps here with you guys.
Oh, okay.
Yeah, like eventually when you get the hang of this, a lot of you won't even do the verification box. Okay, but just as a starter, just to get an idea of what's happening, I have the verification tool.
Okay.
Like when I do them now, I don't use it. I just do it directly, straight up. I know that 1 times 2 is 2, but I'm just doing baby steps here with you.
Okay, thank you.
You're welcome. So let's do number 2. I'm going to give you 3 minutes this time to do it on your own. Okay, go ahead. 3 minutes. I'm going to get more water. I'll be right back.
Dos Santo.
All right, guys. Are you ready to answer? Any volunteers? The what?
Can I do it?
I think it's in the closet. Hadil?
Yeah, can I do it?
Yes. Go ahead.
So for Ca, it's 1 for like the left one, and for
Yeah.
oxygen, it's also 1, and for hydrogen, it's 1, and for chlorine, it's also 1, and for the right side, Ca is still 1, and O is still 1, and you times H by 2, and it's 2, and then you times for chlorine, it's 1 times 2, and it's 2.
Okay. So this is the problem right here. It's not balanced. Now what? What do you have to do, Hadil?
Multiply it by 2.
Yep. Here also. This means on the left side, I have to put a 2 here. That's it. And the rest is all balanced. So the answer is 1, 2, 1, 1. And there's balancing equation. Okay, next one, number 3. I'll give you guys a few minutes to do that one. I'd like to hear Faris for that one. Is he there? Yeah. Faris?
Yes.
All right. I'll give you a few minutes for that one. If you're done with 3, you can move on to 4. Don't finish them all. My son wants to invade the candies that I bought. Okay. Tell me when you're ready, Faris.
Okay, miss. For it's 1, 2,
Yeah.
1, 4,
Yes.
and
On
then
the right.
for on the right it would be 2, 2, 1, 4.
Where's the problem? Sodium. What do I have to do?
Times it by 2.
So where do I write that? Continue. In my equation.
So what do you mean?
Where do I
NA.
write? Where's the coefficient goes? Where do I write in my equation?
You put 2
2 where?
in front of NA.
Yes, in front of NA.
There's already a 2 though, miss.
Over here on the left. There was
Oh,
no
I
2.
thought we were focusing on the right.
No, the right already has 2. The problem was the left. The first in the left, I only had 1. Oops. Stupid thing. At first, I only had 1. So this is not balanced. They have to be equal on both sides, right?
I know, miss, but like I thought you were talking about the right side, like the 2. There's already 1 there, so.
Yeah. So now that we have the 2 on the right, what do I do to the left? That was the question.
Times it by 2, yeah.
Exact. So that's why I put 2 here. So this is times 2 equal 2. Now my final result, 2, 2, 2, 2, 1, 1, 4, 4. That's it. Everything else, I don't need to touch. This is all balanced. And you look, I have 2 hydrogens. I have 2 hydrogens. I have 1 sulfur, 1 sulfur. I have 4 oxygens. I have 4 oxygen. It's good. Okay? Next one. Let's go. Let's hear any volunteers, or do I choose someone? Tyler Lee, are you there? Tyler Lee. Nope. Yes, you want to give that one a try? Sorry, I'm having trouble hearing. My headphones won't connect. Okay. Can you view it at least? Can you see it? Okay. All right, so give it a try. I'll give you a few minutes. You'll be answering. When you're ready, tell me, okay? I prefer if you unmute yourself. It would make life simpler. And those who are finished, you can continue with the following equation if you're done with that. You don't understand it. Okay, this is what I'm here for. So, Tyler, did you print this paper? Not yet. Okay, can you at least write this down on paper? Okay. Look, the goal, Tyler, and everyone else who's not getting it too much, The goal is to have equal amount of elements on both sides, okay? So if this verification tool confuses you, we can try without it. You'll see. So look, I have one aluminum here, right? But here I only have 2. So I have to times aluminum by 2 so that now it's equal. 2 aluminum, 2 aluminum. You see? You're trying to make both sides equal. Now, the other problem I have is iron. I have 2 irons here and only 1. So because I have 2 and only 1 here, I'll times this one by 2. So now the irons are equal on both sides. 2 irons, 2 irons here, 2 irons here. Okay, let's check for oxygen. 3 oxygens, 3 oxygens. That's okay, I don't need to do anything. Let's check for aluminum. 2 aluminum, 2 aluminum. I'm good. So this is balanced. Everything's balanced. So 2, 1, leave it at 1 or leave it blank, whatever you want. There you go. Tyler, does that help a little more? Tyler? See, this is the part that I don't like about online learning, is that I don't see your faces. I don't know if there's a question mark on your face or not. So unless you guys give me indication, I'm gonna move on without knowing that you are not understanding. You have to give me some kind of sign of life. Okay, well, we'll do another one together. So if this verification tool, you can use it now. You say, okay, check. Left, I have 2. Now I have 2. Iron, now I have 2. And now after adding the 2, I have 2. Oxygen, 3. And 3. We're good. Okay. Okay, next one. Number 5. Tyler, write this down. CuO plus C give you Cu plus CO2. Once again, if the verification tool confuses you, you do not have to use it. It's fine. You can use it at the end to verify your answers if you want. I'm going to do this one without the verification tool if it helps. This one, I would like to hear from Angelina. You still there? Angelina, Angelina, are you there? Yes. Okay, perfect. So, want to give this one a try? Hi, Dula, welcome back. Angelina? Okay. How many copper do I have here, Angelina? Okay, this is difficult with no answers back. Oh, Angelina, thank you. I have 1 copper. And how many on the right? Angelina? 1, yes. So, okay, no, so far, so good. Oxygen, how many on the left? Yep. How many on the right? Ah, dun dun dun. There is the problem. So, what do I have to do now on this side, next to copper oxide? Because I have 1 oxygen, but 2 here. So there's a problem. Tell me what I have to do, Angelina. Yes, times by 2. Very good. You put a 2 here. 2 multiplies everything though. So now I'm fine for oxygen, but now I'm back to the square one for copper. 2 coppers. 2 coppers here and only 1 on this side. So now what? Well, times by 1 here. Okay, look, if I put a 1 here, then it doesn't serve me any good. I still have 1 copper, but here I have 2. It's not equal. What I have to do to copper to make it equal to this one? Times by what? Okay, look. Hold on. Let me get out of this for a second. Okay, look at me here. Yes, Veronica, times by 2. Yes. Okay. Look. See, I need Lego pieces. There they are. Okay, watch here. Let's say I tell you I start off with 2 Lego pieces, so 2 coppers, but on the other side, I only have 1. So what's missing here? What do I need to do to the one I'm moving around? Angelina, I'm missing another Lego for this to be equal on both sides. If I have 2 here, I need 2 here too. There is nothing disappears. So here's my second Lego piece. Got it? Now it's equal on both sides. Imagine my head is the big equal sign here. Before I had 2, now I have 2. And what I did, I added a second one here. So, Angelina, does that help a little more?
Can you hear me? Wait.
Yes, is that Angelina? Yes.
Oh, it's
finally.
working.
I can hear you. That's wonderful.
Wait. Okay, there. Okay, can you hear me now?
Yes, very clear. Crystal clear.
Okay.
All right, back to this. So I have 2 Lego pieces here, but only 1. So this means I need what here? What I need to change here?
The 1.
You have to change the 1. The 1's not right. What do I do?
Put a 2.
Yeah. Bingo. So now you check. Again, 2 coppers, 2 coppers. Good. 2 oxygen, because the 2 that's here, Angelina, multiplies everything. It's as if you had invisible parentheses. Okay? So 2 oxygens here, 2 oxygens here. I'm good. 1 carbon, 1 carbon. Ta-da! It's balanced.
Okay.
I have equal on both sides.
I just got confused with the 2 in the on the right side.
This one or this one? The highlighted
That
one?
one. Yeah.
I had to do that because it all started with this one. At first, I had 1 oxygen, but 2 here. So for me to have equal oxygen, that means I need to add an extra one here. That means 2. But by putting a 2, now it causes this to be unbalanced all over again. That's why I have to end up putting a 2. You're like, when you do these problems, you're back and forth, back and forth. You check before, you check after, that sort of thing. Okay, then here,
Okay.
for those who are writing the verification tool, we started with 1, 1, 1, not 1, 2, 1. Then we did times 2 to be equal. And now everything's equal. Equal. 2 equal 2. Simple. Okay, let's try another one. Number 6. Let's hear Veronica. Can you unmute yourself?
Yes, miss, I'm here.
All right. Did you print this paper?
Yes, I did.
Okay. Are you getting the hang of this?
Yeah, I'm fine with
All
it.
right. So I'll give you a few minutes. Try to solve number 6. Are you trying it out, Veronica?
Yes, miss.
Okay. Everyone else too should be trying. Angelina too. Tyler. You have to keep trying. The best way to get good at this is practice. Tell me when you're ready, Veronica.
There's 1 mg, there's 2 oxygen, and on the right there's 1 mg and 1 oxygen.
Yep.
Do you like divide the oxygen or something?
No, you're not allowed to do that. It's all multiplication only. No division, only multiplication.
Divide is stupid.
Veronica, you still there?
Yes, miss. Yes.
Okay, so what do I do next?
Times it by 2 on the right side.
Yeah. There you go. So oxygen is okay, but now magnesium is not, because you just multiplied it by 2. Now what?
Becomes 2 mgO2.
Yes, now I have to add here as well, 2. Is that what you mean? 2 mg?
Yeah.
Yeah. Good job, Veronica. So 2 magnesiums on the left, 2 magnesiums on the right, 2 oxygens on the left, 2 oxygens on the right, because it's multiplied here. 2 multiplies the entire molecule, as if it's an invisible parenthesis here. Okay? What time is it? Okay. Shall we go? How many left do we have? We have 3 more. This one is tricky. I want to do number 7 with you guys. It's a little tricky. And who's up for the tricky one? Vitaly?
Hello, miss. Yeah.
How are you?
Good. You?
Good. Did you do number 7 yet?
I tried it. I mean, it's a bit more difficult than the other ones.
Yeah, this one's a little trickier. So what did you get so far?
So, the N, well, first you have to make them equal, so like on 2 sides.
Yep.
So the N, does it mean that you have to put on the left, you have to put, is it 2?
Right now, yeah. Without
Yeah,
balance.
and then
Yeah.
I think on the right one you have to change it to 2NH. Well,
Well, how many do I have now, Vitaly?
Now it's 2 H's. So
Oh,
on the
yep.
left side, on the left side.
Yep.
And on the right side, there's one N, 3 H's.
All right. So this is totally not balanced.
And then you have to balance it out.
Yeah.
But
Start
I'm not sure how
always
to
with,
do. I'm not sure how to do this step.
yes. This is a tricky one. So that one, you have to find the common multiplier. Like there is a number that both multiply. It
Oh,
gives you the lowest common multiplier.
for H, would it be 6?
Yeah, exactly. So you would do 2 times 3, and here 3 times 2. And now they would be equal. So that means at the hydrogen on the left here, I have to put a 3. And on the right, I have to put a 2.
Is for N, is it the lowest denominator? Is it 2? Or is it
Yeah.
okay, it's 2.
Yeah.
So 2
So
times
now,
1 on the left. 2 times 1 on the left.
yeah, this one stays 1.
Yeah.
And now look, by adding a 2 here, you're fixing nitrogen problem too. Because at first I had 2, and now I had 1. But when I'm adding a 2 here, it solved the problem here also. So now everything's balanced.
Okay.
I think that the issue here was to find the lowest common multiplier. Forget the terminology in math. I think that's the right one. Lowest common multiplier is 6.
Lowest common multiplier or denominator, I'm not sure. I forgot to.
Factor.
Lowest factor? Yeah, I'm not the math teacher, so there's terminology like that. I don't remember. Lowest common multiplier. Le plus petit commun multiple. Ouais, c'est ça. 6. Yeah. So sometimes you'll get like odd numbers, like let's say I don't know, 2 and 7. Well, there's obviously you can't. I mean, you could use decimals, but at this level, I don't want to venture into decimals. It's a whole other ballgame. But right now, there's nothing. So you would do 2 times 7, and you would do 7. Oops, 2 times 7, and you would do 7 times 2, and that gives me 14. You see? So you do that only if you have odd numbers that don't have, like you can't really do anything with them, like 2 and 5, for example. Can't do much with that. Only thing you could do is multiply with each other. 2 times 5 and 5 times 2, and that gives me 10. Got it? But this is as trickiest as it gets, and I don't think it gets tricky like that again. So it is 12:12. If you want, we can continue or stop here. It's up to you guys. We can do, there's like a cool animation on this to show you. I wanted to show you the animation. So can you put on the chat if you want to continue this paper or do the animation? Okay. Sounds good. So yeah, you can try the rest of this paper on your own, and I can post the answers on Schoology. But I wanted to make sure 7, you understood it. Can you put a 5 if you understand the 7, and a 3 so-so? Number 7. 5 or 3? George, are you getting a 10 for that one?
Yes, you are.
All right. You know, at least you guys have an idea. Some kids next year will be clueless about this. You guys have at least an understanding, a basics. That's what the goal of this is. I don't want you to become like experts at balancing equations. That's not the goal. Don't forget, we're just starting out. So at least now you have an idea, okay? So, and the homework of today is the homework of today is on facile learning. This also balancing. Okay, let's do the animation and we'll end with that. Sounds good. So I'm gonna stop this and share the animation. Where are you? Here it is. Oops. Okay. So this animation, you have molecules flying around. We're synthesizing water. We go from hydrogen plus oxygen, give you H2O. Notice how I have 2 white circles, 2 red circles. And on the right side, products are not equal. I only have 1 red circle. So I need some people to volunteer. Any volunteers to tell me what I have to do? Look, what I have to do is either add like molecules like these or remove them. So all right, if no volunteer, I will choose Dula. You back?
Yeah, I'm still here.
Dula? Okay. So do you see the screen clearly?
Yeah.
All right. So tell me what I have to do here. What do you think?
I don't really know.
Okay. Do you see how many red circles do you see? How many oxygens do you have on the left side?
2.
And on the right, I have?
1.
How many oxygen? Just 1.
Yeah.
So what do I have to do, you think, to make them equal?
I add another oxygen.
Yeah, over here, which means add an extra water molecule. Yes, Veronica said it correctly. Add another water molecule. So now, Dula, look, I started with 2 red circles, which is 2 oxygens, and now I have 2 oxygens too. But I have another problem now. Dula?
Yeah.
It's not over yet.
And then now you need to add 2 more hydrogen.
Yes, excellent. There you go. You got the green check mark. The equation is now balanced. Very good. And look, the fun part is as long as you keep the ratio 2, 1, 2, it's always going to be balanced. For example, if I decide to multiply everything by 2, so I go like this. See? So now I have 8 hydrogens on both sides and 6 oxygens on both sides. Same with if I keep going. You see that?
Yeah, I see this.
Yeah, usually though, you have to write the simplest form. But, oh, why does it say it's not about, oh, because of the 5. Yeah, that's not possible. Yeah. So we're back to what it was before. 2. There you go. All right. Okay, next, let's try decomposition. Veronica, you seem to be really good at this. You want to give it a try?
Sure, miss.
All right. So observe the equation. I start off with a salt molecule, NaCl, and end up with sodium and chlorine separated. So I'll give you a second to think about it. What do I have to do?
You need to add an extra salt chloride molecule. I think.
Here?
I think so. Yeah.
Now, count. That makes it 1 chlorine here, 1 green circle, but 4 here. Do you think you...
What's the question? What's the question, Nikki?
Or do you mean over here on the left? Where do you want to add chlorine? On the left or on the right?
I think on the left side, miss.
Yes, because I have only 1 chlorine on the left, but 2 here. This means I need to add here. Yes. Okay, we're on the right track. I have 2 green circles, 2 green circles. That's good. Now,
You
I
need
have
to add
2
a purple circle.
Aha. Bingo, you got it. Green check mark. Yes. So now you verify 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines. You got it. The other ones are too complicated. Let me see if that one works. Yeah, this one too. It's more grade 10. I don't want to confuse you guys. Already as it is, you guys seem to be having a hard time with that. But let's finish with the other paper and we'll be done with that. Okay. Good. So this concludes today's class. Trust me, the more practice you do on this, the better you get. So finish today's paper that I asked you to print. And the Facil Learning has questions on balancing, like Unit 1, Lesson 10 and 8. If you notice, I've updated. There's one more that I forgot to put. It's Lesson 8, Unit 1. Okay? So I'm going to put those as homework. So again, Unit 1, Lesson 10 and 8. And I'm going to give you the rest of what's missing is energy. That's the only topic I didn't get a chance to fully discuss. So if you do the Facil Learning, energy is sufficient. It's not that hard. Okay? Because next week is the last week for science. Next week, we're done. Tuesday, Thursday are the last 2 classes. I'm not going to do anything on June 23rd. I'm going to be doing, next Tuesday, I'm going to do like a mini test on technology. I'm going to do it online with you guys. And Thursday, I'm going to do a Kahoot, a review Kahoot, and I'll let you do the online assessment. There are many people who haven't done it yet, so you can go ahead and give it a try for the online assessment on chemistry, okay? On Schoology. So do you have any questions before I leave?
No, miss.
You're good?
Yes, ma'am.
All right. Well, you know where you can find me. You can send me a message on Schoology, send me an email.
All right.
And I'll be there for you anytime. Okay?
Bye, miss.
Bye.
Bye, miss.